Lesson 2.2, Linear Equations. In this lesson, we're going to learn how to graph linear equations. Should be more of a reteach. And to write equations of lines. As you can see, there are a lot of vocabulary words that we're going to discuss, like what is a linear function, what is a linear equation, dependent variable, independent variable, so on and so forth. So let's get started. Okay, objective 1, graphing a linear equations. A function to graph a line is called a linear function. You can represent a linear function with a linear equation, such as y equals 3x plus 2. Okay, a solution of a linear equation is any ordered pair x comma y that makes that equation true. You can write the solutions of the equations using set notations as x comma y, and read the notations of the set of ordered pairs x and y such that y equals 3x plus 2. Because of the values of the y depend on the value of x, y is called the dependent variable and x is called the independent variable. So example 1, graphing a linear equation. So it says graph the equation y equals 2/3 x plus 3. Okay, there's a couple of ways to do this. First one is choose two values for x and find the corresponding y value and plot the points for each ordered pair. Alright, so let's just do that real quick. Y equals 2/3 x plus 3. So I got y equals 2/3 x plus 3. So we're going to have a graph. I'm going to drop it down right now. And we'll do this relatively easily. So you need to make an x set and a y set. The easiest way to do is always see if we can make x 0 and plug it in. And what you'll find out what y is. Y would be 3. And you can prove that right here because you can just do the equation. Y equals 2/3 times 0 plus 3. So y would equal 3. So x is 0, y is 3. 1, 2, 3. Okay, we need to find one more point. Something that'd be easy to multiply. Well, if x equals 3, wouldn't that cancel the denominator? So let's plug it in. Y equals 2/3 times 3 plus 3. So, doing your math, the 3's would cancel, so it'd be y equals 2 plus 3. So y would equal 5. So when x equals 3, 1, 2, 3, y equals 5. 1, 2, 3, 4, 5. So we have 2 points. Okay, so now we can easily graph. There's our line. You can see it looks just like the one in the equation in the book up top. Alright, again, the most important thing is find easy points to check. Alright, here we go. 1a, graph y equals 3/4x. Okay, so here's an x and a y. So our equation is y equals 3/4 x. So if we made x 0, y would be 0. And if we made x 4, y would be 3. Those are some easy points to plot. So let's plot them. 0, 0, and 4, 3. 1, 2, 3, 4, 1, 2, 3. So it's going to look something like this one. Okay. So I think that would be D. So we have a point at 0, 0, so that one's good. That one's out. That one's 0, 0, and that one's out. The next point is 4, 3. So on D, let's look 1, 2, 3, 4. 1, 2, 3. The answer is D. Next one. Graph x plus y equals -2. So x plus y equals -2. Okay, there's a couple things we could do first and foremost. We could rewrite the equation as y equals -x minus 2. And now we just plug in values for x and solve for y. Okay, that might be, again, the easiest way to do it. Alright, so let's make our xy graph. So when x is 0, we just plug in the equation. Y equals negative 0 minus 2, so it would just be negative 2. So when x is 0, y is negative 2. So that's 0, negative 2. All right, what would be another number we could make? Well, an easy one would be, if x was negative 2, what would y be? So let's look at that. So y would be negative 2 minus 2, which would be 2 minus 2, which would be 0. So how would we plot that? Negative 2, 0. There. Going to the left 2, and going up and down none. So there's my graph. There's my line. So I need a graph that looks like that. Okay, the answer would be B. All right, let's talk about what happens on a linear equation. The y-intercept of a line is the point in which it crosses the y-axis. Okay, looking at this is the y-axis. Remember, y goes to the sky. So where it intercepts there is called the y-intercept. The x-intercept is the line which it crosses the x-axis. Remember, x-axis goes across. You can use the same term to identify the x-coordinate at this point. The standard form of a linear equation is ax plus by equals c, where a, b, and c are real numbers and a and b are both non-zero. You can graph a linear equation in standard form by finding the x and y intercepts. So let's look. Transportation. The equation 3x plus 2y equals 120 models the number of passengers who can sit in the train car, where x is the number of adults and y is the number of children. The graph of the equation, okay? Describe the domain and range and explain what the x and y intercepts read. So we know the equation 3x plus 2y equals 120. Okay, so let's find maximums of each. So y represented number of children. So if there are no children on the bus or on the train, that means 3x equals 120. So divide each side by 3, x equals 40. That means the maximum number of adults on the x would be 40. You can see that down here. That's the most they could have if there were no children. Okay, now do the equation. Rewrite it. 3x plus 2y equals 120. If there were 0 adults, so the x value is 0, we could rewrite the equation as 2y equals 120. Divide each side by 2. Y is 60. So the maximum number of children would be 60. So somewhere on this linear equation, somewhere in this vicinity, holds the true number of people on the train. Okay, the y-axis represents children, and the x-axis represents adults. Okay, using the intercepts to graph the equation, the x-intercept is 40, 0. 40 adults are seated, there are no children. The y-intercept is 0, 60. When 60 children are seated, there are no adults. The number of people is both discrete and non-negative. Both the domain and range of the graphs are limited to whole numbers because we're talking about people. Next example. The slope of a non-vertical line is the ratio of the vertical change to the corresponding horizontal change. You can calculate the slope by subtracting the corresponding coordinates of 2 points on the line. So again, it's going to be vertical change over horizontal change. So vertical change over horizontal change, where x2 minus x1 is not equal to 0. Remember, our denominator can never equal 0. So one way you can think of it is rise over run. Okay, the change of y over the change of x. That's another way to look at it, using the delta symbol. So find the slope. Example 3 is this. Find the slope of a line that passes through two sets of points. 3, 2. All right, 3, 2. And negative 9, 6. So I like to do this sometimes when I'm starting to mess with coordinate plane. So it's got x, y. Alright, for point 1, my x comma y was 3 comma 2. For my second point was negative 9, 6. So my slope is nothing more than my change of y over my change of x. Alright, so let's look at my y's. Let's go with the bottom ones. So you could say y2 minus y1 over x2 minus x1. So that would be 6 minus 2 over negative 9 minus 3. So my slope would be 6 minus 2 over negative 9 minus 3. Or we could write it as 4 over negative 12, which could reduce to negative 1 over 3. So my slope in this case is negative 1 over 3. Easy stuff. Find the slope of the line that passes through negative 2, 2, and 4, 2. So let's go x comma y, point 1, negative 2, 0.2, 4, and 2. So what's my change of y's? It'd be 2 minus negative 2. And what's my change of x? 4 minus negative 2. So my slope is just those over each other. So 2 minus negative 2 is 4. 4 minus negative 2 is 6. So my slope is 4 over 6, which can be reduced to 2 over 3. So the answer would be C. So moving on to the next section. When you know the slope and a point on the line, you can use the point slope form to write the equation of the line. So a line through the point x1, y1 with the slope of m, we can rewrite the equation as y minus y1 equals m, which is our slope, x minus x1, where we have the values for y1, the slope, and x1. Okay? So write an equation given the slope and the point. So we're given the point and the slope. So our base equation is y minus y1 equals m x minus x1. Alright, so we're given a slope of negative 1/2, so we just plug that in. Negative 1/2 x minus, and we're given the points of 8 comma 1, negative 1. 8 comma negative 1. So our x1 value is 8. So y minus our y value is negative 1 equals the slope. So simplify, y minus negative 1 is just y plus 1 equals 1/2 x minus 8. So now we can distribute the negative 1/2. So we're going to get y plus 1 equals negative 1/2 x. Negative 1/2 times negative 8 would be plus 4. So now we got to get it in standard form. So we're going to add 1/2 x to each side. So I'm going to get 1/2 x plus y plus 1 equals 4. So now we got to subtract 1 each side to get it in standard form. And we're going to get 1/2 x plus y equals 3. That is standard form. Next example. Write in standard form the equation of a line with a slope of 2. So our m value is 2. And we have, remember our points x1, comma, y1 with the points of 4 and negative 2. So the standard equation, the point slope equation is y minus y1 equals m times x minus x1. So just plugging in what we have, the values. Y minus negative 2 equals 2 times x minus 4. So let's work this real quick. It's going to be y plus 2, because negative times negative is a positive, equals 2x minus 4. Let's try to get it in standard equation. So let's add 4 to each side. So I'm going to get 2x equals y plus 6. So let's rewrite that. So y plus 6 equals 2x. So subtract y at each other to get the x and the y on the same side. So I get 6 equals 2x minus y, which I can rewrite as 2x minus y equals 6. So do I have a 2x minus y equals 6? Yes, the answer is A. Okay, moving on. Okay, you can try this one on your own if you'd like. I'll give you a second to start. Okay, hopefully you're able to figure everything out and solve it. We have a slope of 5 over 6. My x1 value is 5, and my y1 value is 6. My equation for point slope is y minus y1 equals m times x minus x1. So now we just plug in values. Our y1 value is 6, so y minus 6 equals, our m value is 5 over 6. My x stays, my x1 is 5. So we start off like this. Okay, so y minus 6, we're going to distribute the 5, 6 is 5, 6x minus 25 over 6. Just distributed the 5, 6. Okay, so what I'm going to do now is I'm going to subtract y at each side. So I get negative 6 equals 5 over 6x minus y minus 25 over 6. Now I got to get 25 over 6 to the other side. So let's rewrite this equation, and I'm going to flip it when I rewrite it. 5 over 6x minus y minus 25 over 6 equals negative 6. So my next step is I got to add 25 over 6 to each side. Okay. So what I'm going to have, 5 over 6x minus y equals negative 6 plus 25 over 6. So what do I need to multiply that 6 by to get a denominator of 6? Just 6 over 6. So I can rewrite that as negative 36 over 6 plus 25 over 6. That is going to equal negative 11 over 6. So my final answer would be 5 over 6x minus y equals negative 11 over 6. I just rewrote the whole equation right there. So our answer would be A. Next example. When you know 2 points on a line, you can write the equation by using the point-slope equation. Now, what can we do when we're given 2 points? We can write in point-slope form the equation of line 1, 5, and 4, negative 1. We can write the point-slope equation and substitute the slope for the formula of m. Because what is our slope? Nothing more than the change of the change of y over the change of x. So our point slope form is y minus y1 equals m times x minus x1. Well, let's go ahead and solve for m. Our m value is nothing more than the change of y over the change of x. The change of y, that's xy, would be 5 minus negative 1 over 1 minus 4, which would be 6 over negative 3. So my slope is negative 2. So now I can plug that in. So I can go y minus my y1 value. We'll look at the very first term, 1 and 5. So my y1 is 5 equals my slope, which is negative 2, x minus my x value, which I'm using this term. So my x value would be minus 1. And if it says we can leave it in point slope form, we can leave it in point slope form. So if we're given 2 points, the first thing we have to do is find the slope. And then we can put it in point slope form. So write in point slope form the equation through a line of 5, 0, and negative 3, 2. So here's what I'm going to do. I kind of do this. My first point 1, its value says 5 and 0. The next point is negative 3, 2. So I could find the difference right here just by doing math. So what is 5 minus negative 3? So that'd be 5 minus negative 3, which would be, the delta would be 8. The change would be 8 on the x values. What is 0 minus 2? 0 minus 2 is nothing more than negative 2. So my slope is my change of y over my change of x. So that'd be negative 2 over 8, which would be negative 1 over 4. So now my formula is y minus y1 equals my slope times x minus x1. So y minus, let's use our very first point, y minus 0, y minus y1, so y minus 0 equals my slope, which we solve for right here, of negative 1 over 4 times x minus, I made a mistake there, it should be x1, minus x1, which would be 5. Again, we are using the first point and that slope. So we get y minus 0 equals negative 1/4 x minus 5. So the answer would be B. Next example. Another form of equation is slope-intercept form. This is what we learned earlier in Algebra 1, which you can use to find the slope examining the equation. So it's y equals mx plus b, where m equals the slope and b equals the y-intercept. Find the slope using the slope-intercept form. So we just basically got to solve for y. So I got 4x plus 3y equals 7. Got to get y by itself, so we're going to subtract 4x. Okay, so I got 3y equals negative 4x plus 7. Now I got to divide each side by 3. So that's going to be y equals negative 4/3 x plus 7/3. So my slope, if you look at it, my slope is negative 4 over 3, and my y-intercept is 7 over 3. Okay, so slope-intercept form is going to be y equals mx plus b. Point-slope form is y minus y1 equals m times, in parentheses, x minus x1. Okay, slopes of the horizontal and vertical lines and perpendicular and parallel lines have special properties. A horizontal line, the slope is 0 and the y value is constant. The slope is 0, the y value is constant, which it should be. If it's vertical, the slope is undefined because you can't divide by 0, and the x is constant. It'll be set x equals. Perpendicular lines, the product of the slopes are a negative reciprocal. The products of the slope equal negative 1. Parallel lines, the slopes are the same, but the y-intercepts are different. Example 7, write an equation of a perpendicular line. So the question says, write an equation of a line through each point that is perpendicular to y equals 3 over 4x plus 2. So we know the line we have to write is perpendicular to y equals 3 over 4x plus 2. So what is the perpendicular slope? Well, it's the opposite reciprocal. So if the slope for the first one is 3/4, the slope for the perpendicular line has to be negative 4/3. Okay, so in A, it goes through points 0, 4. So we could say y equals mx plus b and go ahead and just solve for b. Okay, this is one way to do it. So our y value is 4. Our slope is negative 4 over 3. Our x value for point A is 0, so solve for b. So 4 equals b. So now we have our y-intercept and we have our slope. So we can rewrite as y equals m, which is negative 4/3, x plus 4. So for A, this is our equation for a perpendicular line that intercepts 0, 4. Okay, for part B, again, we can use y equals mx plus b. We know the perpendicular slope. We know the perpendicular slope is negative 4/3. So we could rewrite this equation and plug in our 6 and our 1. But first, let's just go y equals negative 4/3 x plus b. That should be a b. And we have an x and a y value. My y value is 1, so plug it in. Y equals negative 4/3 x. My x value is 6 plus b. So 1 equals negative 24/3 plus b. So 1 equals negative 8 plus b. So we can solve, add a to each side, so we find out b equals 9. So we have our b value and we have our slope. So we can rewrite our equation. Y equals m, which is negative 4/3 x, plus our b value, which is 9. So there's an equation that's perpendicular that goes through point 6, 1. 7a, choose the equation for the line described. Choose the equation for a line that goes through negative 1, 3 and is perpendicular to the line y equals 5/x. So we need it to go through points negative 1, 3. And the perpendicular slope would be negative 1/5. Okay, so let's go ahead and plug it in. So we got y equals mx plus b. I have a y value, that's 3, equals my slope is negative 1/5, so negative 1/5. My x value happens to be negative 1 plus b. So 3 equals 1/5 plus b. So subtract 1/5 to each side. Okay. So I'm going to have 3 minus 1/5 equals my b value. So to get 3 to have a denominator of 5, I'm just going to multiply the top and bottom by 5. So I'm going to get 15 minus 1/5 equals b. So my b value equals 14/5. So there's my b value, there's my slope. So I can say y equals my m value, negative 1/5 x, plus b, which would be plus 14/5. So the answer would be D. Okay, review these notes and good luck.